Hey. The topic I am going to discuss is statistical estimation of confidence intervals. Confidence interval. A confidence interval is a range of values that is likely to contain the true value of a population parameter with some level of confidence. Estimation of confidence intervals helps us draw conclusions about a population based on a sample. We usually use sample statistics to estimate population parameters. For instance, we might use the sample mean to estimate the population mean or the sample proportion to estimate the population proportion. However, we know that these sample statistics will not be exactly equal to the true population parameter. Therefore, to understand the uncertainty of our estimates, we need to determine a confidence interval. For estimating a confidence interval, we start with a point estimate of the population parameter, such as the sample mean or sample proportion. Then, we use the standard error of the estimate, which is added and subtracted from the point estimate to create the confidence interval. Confidence interval equals point estimate plus or minus, critical value, into, standard error. Point estimate is sample mean or sample proportion. The critical value is based on the level of confidence desired for the interval and the distribution of the sampling statistic. For example, if we want a 95% confidence interval for a normally distributed statistic, the critical value would be 1.96. If we want a 99% confidence interval, the critical value would be 2.58. The critical value can be found in a standard normal distribution or a t-distribution table or calculated using software. The standard error of the estimate measures the variability of the sampling distribution of the statistic. The standard error of the sample mean is equal to the standard deviation of the population divided by the square root of the sample size. Sigma by square root n. The standard error of the sample proportion is equal to square root, p, 1 minus p, by n, where p is the sample proportion and n is the sample size. In my previous videos, I have already explained more about the standard error of means. Link will be in the description. Formulas. Confidence interval for a population mean. Ci equals x bar plus or minus t alpha by 2, sigma by square root n. Where Ci is the confidence interval, x bar is the sample mean, t alpha by 2 is the critical value from the t-distribution table corresponding to the desired level of confidence, sigma is the standard deviation, and n is the sample size. Confidence interval for a population proportion. Ci equals p plus or minus z alpha by 2 square root, p, 1 minus p, by n. Where Ci is the confidence interval, p is the sample proportion, z alpha by 2 is the critical value from the standard normal distribution table corresponding to the desired level of confidence, and n is the sample size. Remember that a confidence interval gives us a range of possible values for the population parameter based on the sample data. The confidence level tells us how often we can expect these intervals to include the true population parameter in the long run, but it doesn't tell us the chance that a specific interval contains the parameter. Degree of freedom. Degree of freedom refers to the number of independent pieces of information that are available after estimating one or more parameters from a sample of data. Specifically, it represents the number of values in the sample that are free to vary after certain constraints have been imposed. It is usually denoted by the symbol df. The concept of degrees of freedom is important in many statistical calculations and tests, such as t-tests and ANOVA, where the degrees of freedom are used to determine critical values for making statistical inferences. The degrees of freedom depend on the sample size and the number of parameters estimated. In general, the degrees of freedom are equal to the sample size minus the number of parameters estimated. If we are estimating the mean of a sample, we are estimating one parameter, so the degrees of freedom would be the sample size minus 1. df equals n minus 1. Higher degrees of freedom lead to more precise estimates and narrower confidence intervals, while lower degrees of freedom result in more uncertain estimates and wider confidence intervals. Therefore, it is important to understand and take into account the degrees of freedom when analyzing and interpreting statistical data. Thank you for watching. If you found this video helpful, please give us a like. Subscribe for more videos and also share with all your pharma mates. Thank you.